Hi children, in the previous video we discussed about the types of numbers from natural numbers to we discussed up to integers, right? So here in this video we are going to discuss about that fractions onwards. Okay, so see here, ma'am, here fractions is also one type of that numbers or not, if you have the doubt. Okay, so this is about that fractions, but fractions is there in that next type of numbers, right? That is rational numbers. In that rational numbers we have that fractional numbers. So before going to discuss about that rational numbers, we need to discuss about that fractions. Okay, so see here, what about that fraction? So here, part of a whole. What is that? Part of a whole. For example, here take that one box that is divided into 4 equal parts. Or take that one chocolate that is divided into 4 equal parts. Okay, so if you want to eat that one of the part, which one I shaded here, that one already you ate it. Okay, so what part of chocolate you already ate here? Okay, so or what part of that square, what part of that figure is shaded here, means only one part is shaded out of how many parts? Totally we divided into 4 equal parts, no? So here one part out of 4 parts. Already we learned about this one in previous classes, right? Okay. See here. Again I want to shade that another part here. So how many parts are shaded here? 2 parts. So we can write this one as 2 by 4. Okay. And here another part I want to shade it. So how many parts are shaded? 3 by 4 parts are shaded. Okay, how much part is not shaded or unshaded? How much part is unshaded here? Only 1/4 of part is unshaded. Okay children, so this is the way you have to write that fractions. So in that fraction forms, here we can observe that 1 by 4, this one 2 by 4, 3 by 4. Okay, so here we can observe that 3 different parts in that one number. So let us take that only 1 by 4 here. 1 by 4. So in this number only we have the 3 different parts. What are those? Here 1 is that above that bar symbol we have here 1 is there. So this part we will call it as the numerator. What we will call this? Numerator. And below that, below means down of that bar symbol we have another part, that is denominator. That is called denominator. And here what we will call this bar symbol? That bar symbol is called fractional bar or vinculum symbol. What is that? Vinculum symbol. Okay, vinculum symbol or fractional bar. Vinculum symbol or fractional bar. Okay. So here we have that 3 parts, numerator and denominator, and here this is a vinculum symbol. Okay, so here numerator represents, what we can write in that numerator here? Yes, the number of parts we taken, that representation we have to show in that numerator. Okay, and denominator means a total number of equal parts. Total number of equal parts. Okay, so how many equal parts are there here? 4. Okay, so in that all cases we are writing here 4 only. Why? Because this picture is divided into 4 equal parts. So denominator always shows that a number of equal parts, total number of equal parts. Okay, that one we can write in that denominator. Numerator means how many parts we taken from the total number of equal parts. Okay, that is the difference. Okay, ma'am. So here this is about that fractions. So here fractions 1 by 4, 2 by 4, 3 by 4 we are writing like this, no? Okay, 3 by 4, 4 by 4, 5 by 4 and so on here. 5 by 4 again means that is related to mixed fractions. Already you know the types of fractions. Okay, so here these all are that positive fractions. Yes or no? Why? Because all are having positive signs. Sign not given means that is represented to positive only, no? So that's why. These all are that positive numbers. And if you take that negative numbers, just if you taken with a negative sign, minus 3 by 4 and so on. Okay. So here these all are that positive fractions and these all are that negative fractions. So here we can say that non-integral positive fractions, non-integral negative fractions. Okay, so this is about the fractions. Fraction, this is also in the form of a by b. Okay, so here numerator, denominator, and that separation bar is called fractional bar or vinculum symbol. Okay, so here fractions, here we can take that along with negative signs also. So we will call that positive fractions as non-integral fractions and negative fractions as non-integral fractions with negative sign. Okay children, so this is about that fractions. Why madam here you discussed about fractions means? Here these two including, these two also including in that rational numbers, no? So that's why. So what about that rational number? Let us see that. Rational numbers. Okay, see here rational numbers. What about the rational numbers? If a number which can be written in a p by q form, okay, a number which can be written or which can be expressed in p by q form. So here which can be expressed means, for example here 2 is there. For example 2 is there. 2 we can write it as 2 by 1. 2 we can write it as 2 by 1. So here a number which can be expressed, a number which can be expressed in p by q form where q not equals to 0, okay, is called a rational number. Is called a rational number. So once again observe this definition here. A number which can be expressed in p by q form. So any number we can expressed in the form of p by q by taking 1 as its denominator. Okay, here 2 I taken. Next for example minus 3. Minus 3 is an integer. We know that, right? So minus 3 I can write it as minus 3 by 1. Okay, again minus 3 by 1. Its value is again minus 3 only, no? There is no change in its value. By taking 1 as its denominator, then also there is no change in its value, right? So that's why here minus 2, minus 3, minus 4. So any integer, even 0 also we can write it in the form of fraction by taking 1 as its denominator. Okay, so all the integers also we can say that all the integers are rational numbers. So each and every rational number we can express in that p by q form. And here I given one of the condition. What is that? Q not equals to 0. Why madam q not equals to 0? Because for example 0 by 2 is there, okay, and 2 by 0 is there. Okay, what is the meaning of 0 by 2 here? After cancellations, 2 ones 2, 2 zeros 0. 2 into 0, 0. Okay, if you multiply any number with 0, then again you will get it as 0 only the answer. Here, come to this one. 0 into 1 is equal to 0. Clear? 0 into how much is equals to 2? Is it possible to get 2? If you multiply 0 with any number, is it possible to get that 2 as a quotient? It is not possible. Why? Because 0 into any number, again you will get it as 0 only. Okay, but here we need to get it as 0 or 3 by 0. We need to get it as 3 as a quotient. It is not possible, no? So that's why here 2 by 0 is undefined. Okay, any number divides by 0 is undefined, and 0 by any number is always 0. Okay, so that's why here q not equals to 0. So q is equals to any integer. Okay, but here q is not equals to 0. Okay, by using that conditions here, if that numbers which are in the form of p by q where q not equals to 0, those numbers are called rational numbers. Okay, is called a rational number or numbers. Clear ma? So after that we have here terminating decimals. Okay, 2 by 2 is 2. 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 2 by 2 is Why madam, up to now you are discussing about numbers only, no? Why suddenly you went to that decimals? Yes, decimals also a rational number. Okay, how it will be? See here, which decimals are rational numbers? So rational numbers means we are saying that all the natural numbers are rational numbers, all the whole numbers are rational numbers, all the integers are rational numbers. Here come to that decimals. Decimals means here how madam you are saying that is a rational number? Decimal means a point something is there, no? So how you are saying that is a rational number? See here, for example 0.3 is there. What is that? 0.3 bar. Okay, just keep this one aside. Here before that I am going to tell you, for example 3 by 10 is there. What is that? 3 by 10. Okay, so this one how we can write it? 3 by 10 means 0.3. Shall we write like that? Okay, 3 by 10. So we can write this one as 0.3. Okay. So by converting that decimal into that fraction, here possibility there or not? Possibility is there. Okay. 0.33. How we can write this? 33 by 100. 33 by 100. 0.333. 333 by 1000. Okay, why? Because already we know that fractions have to write in the decimal form into that fraction, we know that by taking it denominator as powers of 10. Okay, so here I am going to take this one as 0.333 and so on. So what is the meaning of this one? 0.333 and so on means here there is no ending point. While observe that the first one 0.3, how many decimal places are there? 1. Here how many decimal places are there? 2. Here how many decimal places are there? 3. Here how many decimal places are there? We don't know that. Why? Because here continuation and so on is there. And so on means here there is no ending here. Okay. So here which numbers are having that, which decimal numbers are having that terminating point? Terminating point means ending point. Here we can say that number of digits there in the decimal places. Okay, those decimals are known as terminating decimals. Those are known as terminating decimals, which are having exact number of, okay, finite number of places. Okay, so just like that, for example, take that 5 by 2 is there. 5 by 2, how we can write that? 2 2's 4 and 2 5's 10. So 2 into 2.5 is equals to 5. Are you agree with that? Yes. Here how many decimal places are there? 1 decimal place is there, right? So here we can say that number of decimal places we can say here. Okay. So that's why this type of decimals are known as terminating decimals. Those are known as terminating decimals. Okay. So these terminating decimals again we can write in the form of A by B, in the form of P by Q. Right? So that's why here terminating decimals are also known as rational numbers. Are also known as rational numbers. Terminating decimals are also known as rational numbers. Am I clear? Next. Here what about this one, ma'am? 0.333 and so on. Here this type of numbers, is it possible to convert in the form of P by Q or not? Yes. See here. 0.333 and so on, right? So here which number is in repetition? 3 is in repetition and so on is there, means the last digit what is there, that one is in repetition, that is the meaning, right? So here 0.333 and so on, so we can write this one as 0.3 bar. Okay, bar represents that, under that bar which number is there, that number is in repetition. Okay, that number is in repetition. So this type of decimals we will call them as non-terminating recurring decimals. Non-terminating recurring decimals. So what about that? Recurring means repeating. Non-terminating recurring decimals, which means recurring means repeating decimals. Those decimals are non-terminating. There is no ending point. But here the condition is one of the number is in the same number is in repetition. The same number is in repetition. Okay. So in this way we can say that non-terminating recurring decimals or non-terminating repeating decimals, we will call this one. So non-terminating recurring decimals are rational numbers or not. Okay, I'll tell you one example. See here. Here some x is equals to 0.3 bar is there, no? So that one I am going to write it as 0.333 and so on. Okay, x is equal to 0.333 and so on. So here point after how many digits are having bar symbol here? Only one digit is having bar symbol. One digit is there means I want to take it as multiply with 10. Okay, for example 0.33 bar is there. So two numbers having bar, then I want to multiply with 100. Okay, or 0.666, three numbers there. So I want to multiply this with three zeros. Okay, one after three zeros, which means 1000. Okay, so here point after how many digits having bar symbol? Only one digit. So I want to multiply this one with 10. So 10 into x is equal to 10x. Okay, so this one also I want to multiply with 10. So if your decimal number, if you multiply with 10, then we have to move that one of the digit. This point is there, no? Decimal point moves which side? Right side. How many points after? Only one digit after we have to keep that point. Why? Because here we are multiplying with 10, no? So that's why. So this one we are getting as 3.333 and so on. Okay. So this is that equation number 1. And this one I am going to take it as 2. So here 1 minus 2 I want to do. Subtraction. So here 10x is equals to 3.333 and so on. And here one equation. What is that one? This is the one and the second equation. So x is equal to 0.333 and so on. I want to subtract these two here. Okay. So 10x minus only 1x. Okay. So 10 minus 1 is 9. 9 times of x, which is equals to 3 minus 3, 3 minus 3, 3 minus 3. Okay. We are getting here zeros. 0.3 minus 0 is 3. Okay. So 3.00 means which is nothing but that 3 only, no? So 9x is equals to 3. Okay. So from this one x is equals to 3 by 9. So 3 ones 3 and 3 3s 9. So x is equal to 1 by 3. So children, just observe that here x is equals to, I taken that 0.3 bar. Okay, that is in decimal form. That decimal number here, that one comes under that rational form. Yes or no? Here we got that x is equal to 0.3 is there. Here we got that x is equal to 1 by 3 form here. Yes or no? So 1 by 3 means that is p by q form only, no? So p by q form means which number that is? Yes, that is a rational number. So that's why here non-terminating recurring or repeating decimals. Recurring or repeating decimals are also known as rational numbers. Am I clear to you? Okay. So here any non-terminating repeating decimals also we can say that one as rational numbers. Okay children. So here which numbers are rational numbers? A number which can be written in the form of p by q as well as q not equals to 0. And here terminating decimals are also known as, terminating decimals also we can write in the form of a by b or p by q. So terminating decimals are also known as rational numbers, as well as here non-terminating recurring or repeating decimals are also known as here rational numbers. Okay children, so this is about the rational numbers, and here up to now we are discussing about that bar symbol, right? That one only vinculum symbol. So 0.666 and so on. This one we can write it as 0.6 bar. Clear? For example, 0.232323 and so on. Now here which number is in repetition? Yes, 23 is in repetition. So we have to keep it as 0.23 and bar. Okay. And here 0.251, 251, 251 and so on. So here which number is in repetition? Yes, 251 is in repetition. So we can write this one as 0.251 bar. Understand children how to write that bar symbol here? Okay. So here we have that another concept, that is the period and periodicity. What is that? Period and periodicity. So what about that period and periodicity? Here period means the number which lies under that bar symbol, or the number which is in repetition in that decimal part, that is called period. The number which is in repetition, that is called period. Number of digits are in repetition, that is called periodicity. Okay, once again I am telling that which number is in repetition, that is called period. Number of digits in that number is in repetition, number of digits, that is called periodicity. So here for example 0.2351 bar. Okay, so which means here 0.2351, 2351, 2351, 2351 and so on, that is in repetition, right? So here period, bar under which number is there? 2351, that is the period. And periodicity means how many digits are in repetition? 1, 2, 3, 4. So this is the periodicity. Understand? How many digits are in repetition? That is the periodicity. Okay, I'll tell you one more example. 0.65432. So here bar symbol is there on that 5 onwards. So observe that here. What is the meaning of this one? Means here 0.65432. 5432, 5432 and so on. So children, here the number 6 is not in repetition. 5432, 5432, 5432, that is in repetition. 6 is not in repetition. Why? Because the bar symbol is not there on that 6. Okay, so that's why. So here period is 5432 is the period. And what is the periodicity? Again 4. Okay, maybe here 5 times there, 0.796853. Okay, so here what is that period? Yes, 796853 is the period. And what is the periodicity? 1, 2, 3, 4, 5, 6. 6 is the periodicity. Understand children? So this is about that period and periodicity. Okay, so after this one we have that irrational numbers. What is that? Irrational numbers. So children, rational numbers we discussed now. So rational numbers denoted by the letter, yes, Q. Rational numbers denoted by the letter Q. Why? Because ma'am, that is Q means Q is that quotient. Q is means quotient. So rational numbers depends on that quotients only, no. 2 by 1, that is the rational form, but its value is 2. Okay. 4 by 2, that is the rational number, but its value is 2. Okay. So here always depends on that quotient only, no. So that's why here rational numbers denoted with the letter Q and irrational numbers denoted by the letter Q dash. Irrational numbers denoted by the letter Q dash. Okay. So here irrational numbers means what? The numbers which we cannot written, which cannot be written in the form of P by Q. Which cannot be written in the form of P by Q. Okay, those numbers are known as irrational numbers. Okay, and here we can say that root 2 is an irrational number. Why? Because root 2 value is 0 point something you will get. Okay, so here non-repeating, non-recurring decimals are known as irrational numbers. What is that? Non-terminating, non-recurring, non-terminating and non-recurring decimals. Okay, so here before we discussed about that terminating decimals and non-terminating recurring decimals. But here non-terminating, non-recurring decimals, which means here that decimal numbers are not having ending point and that is not having same numbers is in repetition. Okay, same numbers are in repetition, that one also not there. So that type of decimals are known as here non-terminating, non-recurring decimals. Example is 1.2351262 457 and so on. See children, here is there any repetition? Here we cannot say that 2 is in repetition. Why? Because in between 2 we have that some other numbers. Repetition means continuationally we will get it as. Okay, 0.333 and so on. That is the continuation. Okay, but here this is not repetition. Okay, so here ending point is not there and the numbers also not in repetition. So that's why here this type of decimals are known as non-terminating and non-recurring decimals. So this type of decimals are also known as irrational numbers. Okay, why madam here you written that root 2? Root 2 value is 1.414 and so on you will get. Okay, 414 and so on. Here also this is non-terminating, non-recurring decimal. So that's why here root 2 is an irrational number. And root 3, root 5. Is it possible to say that root 4 is an irrational number? Why? Here yes ma'am. Why? Because here root symbol is there. No, that's why root 4 is an irrational number. No. Why? Because root 4 is equals to 2 square. Okay, so square and root gets cancelled, so its value is 2. Already I told you that rational numbers and irrational numbers depends on that quotient values. Quotient answer in that division form. Okay, so here quotient is 2. So 2 is a rational number. Okay, so 2 is a rational number, that's why that is not irrational number. 2 is a rational number, root 2 is an irrational number. Okay, that is the difference ma. So why? Because 2 is a rational number means square root of 4 is 2. Okay, so that's why 2 is a rational number. And square root of 2, that is not having a perfect square. Okay, root 2 is not a perfect square, right? So that's why here root 2 is not a perfect square, 3 is not a perfect square, 5 is not a perfect square. Okay, as well as 6 is also not a perfect square. Okay, so that's why root 7. Okay, root 8, root 9, again that is not a perfect, again that is a perfect square, no? So that's why here root 9 is not a irrational number, root 9 is a rational number. Okay, understand children? So here root 2, root 3, root 5, root 7, root 11, root 13, okay, these all are the numbers are example for that irrational numbers. As well as here pi value. Pi means 22/7, so just we are saying, but that is not the exact value, that is the assumed value. Okay, there is a lot of difference in between exact value and assumed value. Okay, 22/7, it is not an exact value, just assumed value is 1 point something they will give. Okay, 22/7. Actually, this is the pi, right? So 7 is 21. So 3 point something you will get here, 14 and so on. Okay, 3.414 something you will get here. So that is generally we are saying 22/7 P by Q form is there, no ma'am. So that is the rational number. No. Why? Because this is the assumed value, not exact value. So that's why here pi is an irrational number. As well as small e. E means also 0 point something, 2 something you will get. Okay, largest number, decimal number you will get. Okay, so that's why pi e. Those two also examples for that irrational numbers. Okay children, so in this video we discussed about that fractions, rational numbers. About the rational numbers we discussed everything, right? So after that we discussed about that irrational numbers. So in that next video we are going to discuss about that real numbers, imaginary numbers and complex numbers. Okay children, thank you.